Sixth grade, Module 6, Lesson 11, Classwork. Example 1. In Lesson 10, data distribution was characterized mainly by its center, mean, and variability, MAD. How these measures help us make a decision often depends on the context of the situation. For example, suppose that two classes of students took the same test and their grades based on 100 points are shown in the following dot plots. The mean score for each distribution is 79 points. Would you rather be in Class A or Class B if you had a score of 79? So if you're looking at Class A scores, it ranges anywhere from someone got a 60 to someone got maybe a 92 or so. And the mean here is 79. So say you got 79 here, and you also got, this would be 79 here. But here, the lowest score looks about 77, and the highest score is 81. So this is kind of an opinion. I personally would rather be in Class B if I got a 79, because that means there weren't that many people that scored above me. And whereas in Class A, some people got in the 90s, but maybe you'd rather be in Class A because you did better than all these people. I mean, there's really no right or wrong answer there. So exercises 1 through 6, looking at the dot plots, which class has the greater MAD? Explain without actually calculating the MAD. Okay, so who has the greater variability? So if the mean, again, was 79, there's 79, here's 79. Which one has the greater variability? Well, Class A goes all the way from 60 to 91, whereas Class B only goes from about 77 to 81. So it would be Class A has a much greater MAD because there's a lot more variability. People scored a much wider range of scores than Class B. So let's say Class A has a much wider spread than B, so there's much more variability, much greater variability, and a larger MAD. Number 2, if Liz had one of the highest scores in her class, in which class would she rather be? Explain your reasoning. Okay, so if Liz had one of the highest scores in her class, which would she rather be? So the highest score in Class B, about 82, but the highest score in Class A is a 92. So she would rather be in Class A because she could get a higher score. She had a higher score than if she would have had in Class B. So Class A, because Class A had higher scores in the 90s, and Class B had a high score of 81. Number 3, if Logan scored below average, in which class would he rather be? Explain your reasoning. So say you scored below average. Well, if I scored below average, I'd much rather be in Class B, because then I'd maybe have a score, might be 77. Whereas if I scored below average in Class A, I'd maybe be in this 60, 65 range. So much better to be in Class B if you scored below average. So Class B, because the low scores were in the low 70s, but Class A's low scores were in the 60s. So you'd rather have a higher score, 70, than the 60s. Your little brother asks you to replace the battery in his favorite remote control car. The car is constructed so that it is difficult to replace its battery. Your research of the lifetime in hours of two different battery brands, A and B, shows the following lifetimes for 20 batteries from each brand. So we have brand A and all of those different times, and then we have brand B. To help you decide which battery to purchase, start by drawing a dot plot of the lifetimes for each brand. All right, so we have brand A, brand B. Let's see what they kind of range for them. So for A, the lowest I'm seeing is maybe 12, and the highest being 27, whereas brand B ranges from 18 to 22. So let's make our chart maybe like 10 to 30. Let's do that. We could count by twos. Let's do 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. And then I'll make another one for brand B. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. Okay, so brand A, let's do brand B. Let's say time in hours. And this is brand A. Time in hours. Okay. So let's start plotting. For A, we have 112, 2 14s, a 15, a 16, 2 17s, 1 18, 1 19, 1 20, 2 21s, 2 23s, 3 24s, a 25, a 26, and a 27. Okay, brand B, we have 2 18s. We have, let's count up, 1, 2, 3, 4, 5, 6 19s. How many 20s? 1, 2, 3, 4, 5 20s. 1, 2, 3, 4 21s. And 3 22s. All right, so there's the difference in our dot plots right there. Number 5, find the mean battery lifetime for each brand and compare them. So to find the mean, we're going to add all of them together and then divide by however many there are. Does it say how many there are? Yeah, 20 battery brands. So we're going to add them all up and divide by 20. I'm getting out the calculator for this. Okay, so we have, let's start with brand A. 12 plus 14 plus 14 plus 15 plus 16 plus 17, 17, 18, 19, 20, 2 21s, 2 23s, 3 24s, a 25, 26, and 27. So we get 400. Divide that by, there are 20, and we get 20. The average is 20. or the mean. So we got 400, we divided it by 20, and we got 20. So the mean for A, brand A mean is 20 hours of charge, lifetime. And brand B okay, let's add up all of brand B. So we have 2 18s. So I'm going to do 18 times 2 plus 1, 2, 3, 4, 5. It's 6 19s. 19 times 6. Plus, we had 1, 2, 3, 4, 5 20s, which would be 100. Plus 1, 2, 3 21s, which is 63. Plus 3 22s. Oh wait, 1, 2, 3. We had 4 21s. Plus 3 22s, which is 66. So 400 again, divide that by 20. So again, the mean of that is also 20. So brand B mean, so this was equal to 400, and we divided it by 20 again and got 20. So brand B mean is also 20 hours. Looking at the variability in the dot plot for each set, give one reason you might choose brand A. What is one reason you might choose brand B? So we're looking at the variability. Why might we choose one over the other? Oh, sorry, I forgot to compare them. So you could just say they're the same. Say they have the same mean lifetime. Okay, looking at the variability in the dot plot, give one reason you might choose brand A. What's one reason you might choose brand B? We might choose brand A because you could get a lifetime battery above 20 hours. So say the mean is 20, like, I don't know, maybe you might get one that has a lifetime of 27 hours, which would be a really long time. But then you could also, bad news, you could also get one that only has a battery life of 12 hours. So if you're more of someone who likes to take a risk, brand A might be for you. If you're someone who likes consistency and wants to buy something knowing like, all right, I might not get much more than 20 hours, but I'm definitely probably going to get 20 hours, brand B is for you. Let's say brand A, I could get a battery that lasts much longer than 20 hours. But I could also get one that lasts much less than 20 hours. Let's say brand B, I would always get a battery, I don't know why it's doing that, a battery that lasts about 20 hours. So it just depends like what kind of gamble you want to take on that. Okay, example 2, comparing distributions with different means. You have been comparing distributions that have the same mean but different variability. As you've seen, deciding whether large variability or small variability is best depends on the context and on what is being asked. If two data distributions have different means, do you think the variability will still play a part in making decisions? I think variability is always going to play a part in making your decision. So I'm going to say yes. Let's say considering the variability will always it'll always just give you more information about the data set. Will always give you more information, info about the data set, and help you to make informed decisions. Exercises 7 through 9. Suppose that you wanted to answer the following question. Are field crickets better predictors of air temperature than katydids? Both species of insect make chirping sounds by rubbing their front wings together. The following data are the number of chirps per minute for 10 insects of each type. All of the data were taken on the same evening at the same time. Draw dot plots for these two data distributions using the same scale going from 30 to 70. Visually, what conclusions can you draw from the dot plots? So we're going from 30 to 70. Let's make a dot plot. I'm going to count by, we're going 30 to 70, so I'm going to go by fives because that's a pretty big range. So 30, 35, 40, 45, 50, 55, 60, 65, 70. So let's call this one crickets. And number of chirps. Let's set up the next one. I like to set up the plots first. You don't have to. Just maybe my least favorite part, so I like to just get it over with. So 30, 35, 40, 45, 50, 55, 60, 65, 70. Number of chirps. All right, got that done. Now we can plot. So we have 35 for crickets. I'm going to start with crickets. We have 35. We have a 32. Another 35. A 37. 34. Another 34. A 38. Another 35, 36, and another 34. Okay, so crickets are all pretty much spaced down here in the 30s, somewhere in the 30s. And katydids, we've got 66, 62, and 61. 66, 62, 61, 64, 63, 62, 68, 64, 66, and another 64. All right, so there are katydids. They're all up there in the 60s. They do a lot more chirps than the crickets. Calculate the mean and MAD for each distribution. Okay, so to find the mean, we're going to add all these together and then divide by 10. So I'm going to my calculator. Okay, crickets. We had 35 plus 32 plus 35 plus 37 plus 34, another 34, 38, 35, 36, and 34. So we got 350, divide that by 10, and we get 35. So the mean is 35. And then for katydids, let's find the mean for that. We had 66 plus 62 plus 61 plus 64 plus 63, another 62, 68, 64, 66, and 64. We got 640, divide that by 10, and the mean is 64. So these are the means. All right. Now we need to find the MAD. So first we need to figure out the deviation from the mean. Now that we know the mean, we can go forward with that. So I'm going to, because it's easier to look at this way, I'm going to get rid of that so I'm not confused by it. And here is, the crickets are the pink one. Okay, so we're finding how far away each of these are from the mean 35. So 35 is 0 away from 35. 32 is 3 away. 35 is 0 away. 37 is 2 away. 34 is 1. 38 is 3 from 35. 36 is 1 away. And 34 is 1 away. So to find the MAD, we're going to add those up. We have 3 plus 2 is 5, 6, 7, plus 3 is 10, 11, and 12. So we got 12, and let's divide it by the 10. 12 divided by 10 is going to be 1 and 2/10. So the MAD for the crickets is equal to 1 and 2/10 chirps per minute on average. Okay, and then let's do the katydids. I'm going to do that in purple. So the mean was 64, so let's find how far away these are from 64. 66 is 2 away, 62 is 2 away, 61 is 3, 64 is 0, 1 is 2 away, 4, 64 is 0, 66 is 2 away, and 64 is 0. So let's add all of those together. 2 plus 2 is 4, plus 3 is 7, plus 1 is 8, plus 2 is 10, plus 4 is 14, plus 2 is 16. So we have 16 divided by 10 is equal to 1 and 6/10. So the MAD is 1 and 6/10. Here the mean was 35, and here the mean was 64, right? Yes, okay. Number 9, the outside temperature T in degrees Fahrenheit can be predicted by using two different formulas. The formulas include the mean number of chirps per minute made by the crickets or katydids. A, for crickets, T is predicted by adding 40 to the mean number of chirps per minute. So crickets is going to be T, their temperature is going to be equal to the number of chirps, or by adding 40 to the mean number. So the mean number was 35, and we add 40 to it. So the value of T, 35 plus 40, is equal to 75 degrees. So that's going to be the temperature there. For katydids, T is the predicted by adding 161 to the mean number of chirps per minute and then dividing the sum by 3. So the mean number was 64, so it's by T is equal to 64 plus 161 and then dividing the sum by 3. So 64 plus 161 is 225, and then do 225 divided by 3. 3 can't go into 2, but it goes into 22 7 times. And then 3 goes into 15 5 times. So we got 75 again. So C, the temperature was 75 degrees Fahrenheit when these data were recorded. So they were both 75 degrees when this temperature was recorded. So using the mean from each data set, give an accurate prediction of temperature. If you were going to use the number of chirps from a single cricket or a single katydid to predict the temperature, would you use a cricket or a katydid? Explain how the variability in the distributions of number of chirps played a role in your decision. So let's look and see who had a smaller MAD, because that's who I would use, whoever has the smallest variability. So I would use, let's see, we have 1 2/10 and 1 6/10. So I'm going to use the crickets to be the best predictor because they have the least amount of variability. Now, to be fair, the variability is not far off. I mean, it's not like 1 is a 10 and 1 is 1. They're pretty close, but still, I'm going to use the crickets because it's a better indicator. Let's say the crickets had a smaller MAD. This shows that an individual cricket, so if you picked any random individual cricket, would be more likely to have the number of chirps close to the mean. And that is it. That's all. I'll see you for the problem set.